Okay, so the last section I wrote 7.3 traversal composition, which means that we're on this section here, traversal actions. And you'll note that I wrote 1916 traversal actions, but those are the answers to the exercises in 19. So this is, oops. So this is really 7.4 traversal actions. Let's see here. Yep. And yep. Okay, cool. Let me also get this off the desk. All right. I might want to just quickly run through the code that we've already done, since I haven't looked at this in what feels like a very long time. So it's going to be important that we just review what we have done already, just to make sure. Good. So let's go back up and start looking at this. Oh, we're not using this. What the hell? Okay, I don't know what I'm doing wrong. Here, okay, let's start up here. So, all lenses are valid traversals, but the reverse isn't true. Okay, and then I think we're just looking at some. So this is probably going to produce yep. So both over that. This is both set. So I'm gonna guess that both of them become blossom. We should get a tuple with their lengths. Cool. Yeah, and then we have this both combinator, and but there's also this each combinator. We can do it for anything like that. Okay, taking 3 traversed. I think this is times over something, over using the times. So E should probably be 1, 2, 3. So 10, 20, and 30. Oh, okay, right. So taking 3 just gives, it's focusing on the first 3, but I'm not changing the focus. So we just multiply the first 3. And then the same thing is true here, except we get 40 and 50, I guess. Yep. Okay, cool. Basically, I'm just quickly making sure I understand what I'm doing here. Okay, so once upon a time, optics became mainstream. So taking while not equal this, so everything up here should be uppercase, I guess. Yep. Okay, so traversed, filtered even, so even numbers should be multiplied by 10. Yep. Hey, so I noticed somebody's viewing, so if you're willing to chat, let me know how the audio is. If you feel like you hear too much background noise, I can adjust the noise gate a little. But this room seems weird for noise gate. I can't quite get it correct. Okay, so Hey, Chexer, what's up? So short, much longer. So we're going to stream features. Sure, with eye tracking. What what would it do? What do you want to accomplish with eye tracking, I guess? Oh, to see what I'm reading. Oh, that's kind of interesting idea. Yeah, sometimes I'll highlight sometimes what I'm reading, but yeah, I could see how that could be really interesting. Toby. Does it work on Linux? Let's look it up because I'm actually it's actually really interesting. Toby eye tracking device. Eye tracking for PC gaming. It's a little concerning because it says PC gaming specifically. Oh, yikes. Uh, yeah. I don't think this will work for me. The last gen, okay. Um, broadcast. This would be super cool from this standpoint. I could see this being super powerful. Like being able to watch like your favorite um gamers or whatever. Um but I don't really know. I'm not sure where to look right now. Okay, this is pretty useful. Oh, it's on the viewer end. That's actually sweet. Uh formerly. No, this is really interesting. This seems to work with so this is the concerning part is that it only works with Streamlabs or something. Because Streamlabs doesn't work. Anyway, this is kind of interesting, so I'll keep that in mind. Because that would actually be pretty sweet if you could turn on and just be like, oh, he's looking at this now. Uh, if you wanted to, you don't need to turn it on, but you have a choice. That's cool. Might help some people anyway. Okay, so anyway, let's keep going. So I think what this does is say for yeah, uh, I mean the idea is really interesting. The problem is cost, I guess, because there's like other things that I would like to buy for my streaming setup that would be way cooler from an interactivity standpoint. Um, like for, I've been thinking that on this wall to my right, that you can't really see it, but it would be sweet if I could have a like a dry erase board and we could do more mathy type stuff on the stream. That would be really fun. Watch me struggle with that as well. Um, anyway, so yeah, so much longer. Yeah, that would be. I think that's like way more important from a stream standpoint. And what that means is like I need to get a better camera setup. So like I just have this little dinky um, camera in front of me, but I would need to get something more serious, like mountable, maybe in this corner so that I could like point it over that way. And then also the microphone is kind of static, so it's just complicated to get that stuff done. Yep. So that's exactly what happens is we focus on the um, greater than length 5 elements, and then we reverse them. Okay, let's see what we got here. So traversed over take 3. So I'm guessing that for K, we just get bat and sup. Right, because we're not using both here. I think if we stuck a both in here, um, oh wait, both is a traversal. So we would just do both over take 3, I guess. Oops. And then, oh, right, reload. Okay. Okay. All right. And then, okay, so we now have a map with the keys of some of our favorite Dragon Ball Z characters, and we're gonna work with them. So we traverse them, and I think by default we're talking about scores, which is true because we can see like 9. Then over 9,000, else show n. So what does this print? It's probably gonna print the map in some syntax with replacing this with over 9,000 and those with strings, I guess. Oh, yeah, right. There's this from list constructor that lets us print this out. Okay. So now we have a tree of things, and then we're gonna reverse all of the I guess everything? Yep. I'm blanking on terminology here, but I guess these are leaves, so we're reversing all the leaves. Okay, and then this is to list of worded traversed set hello. So I think, oh, it says that right here, but this will be hello, hello, hello. Yep. Why did I show both of those, I guess? I think I was just trying to understand how worded worked. Ah, yeah, we found this as well, which is useful. This is a little more difficult to look at, or to read, I suppose. So what does P do? Yeah, that's cool. All right, now this one is when we start talking about sort of reaching into different structures to have multiple focuses. So I think beside means that we need to have 2 separate structures to focus on, and then the first one, so in this case because we have a tuple, we're okay, and then we use the identity operator to get at the first one, and then we say _2 to get at this, then we focus on those and then append a append a exclamation point. So R should be this same structure with these things having an extra exclamation point. Yep. All right, and then let's see. So this one, beside traversed both. Okay, so we'll traverse the list over both of these numbers and then traverse this and then add 1 to each of them. So we should get 2, 3, 4, 5, 6, 7, 8, I guess. Yep. Okay. What does this do? I think that this just creates the list 2 to 8. T. Yep. Or sorry, we don't add 1, so just 1 to 7. Okay. So left 1 to beside both id negate. So I guess that this implies that we're... Hey Thrashton, how's it going? I feel like I haven't seen you in a while. Doing well. How are you? Is the stream holding up okay at 1080? It seems like it is, so that's good. They came and fixed the internet today. Well, not fixed, but upgraded. They almost installed the exact same internet that was already here, but luckily we caught that before we left. So it should be slightly better. Although my camera doesn't look like it's running at 30 frames a second. Too hot. Yeah. Starting to, well, it's not so hot here, but of course, yeah, you can ask me random Haskell questions. I can't guarantee that I can answer it, but I'll try. If not, like, we can look at it. That's totally fine. All right, so I think for you, we're gonna get left 1, -2. Because I'm gonna guess that the beside is over the either, not over the tuple. Oh wait, no, because okay, I see. So it will be over the either, but on the left side we're using a both. So we should get -1, -2 inside of the left. That's what I think. Yeah, and that's what happened. Okay, I understand in Haskell there are both mutable and immutable vectors in data vector. Is it a vector of references or a vector of values? I don't really know. To be fair, I've never used vector, but I vaguely remember there being unboxed vectors, but I don't... Yeah, so there's unboxed and boxed. Yeah, so you can get unboxed vectors from here. To be fair, I've never used these things. Yeah, there are both. Yep. And you can get, it looks like you can get mutable and immutable vectors in both boxed or unboxed styles. Hey Ken, what's going on? New Vu, yeah, we moved from Pittsburgh to Boston. So my girlfriend's starting a job here and I'm gonna work remotely. Vectors of either A. Oh yeah, I don't know, to be completely honest with you, I don't fully know the difference between boxed and unboxed at this point. Yeah, I knew what you meant. Yeah. Pittsburgh soon. Cool. Pittsburgh's actually really nice. The only thing that I would say that I already don't miss from Pittsburgh is the groceries. The groceries are not very good there. Like produce. But that's, I mean, that could be minor. So if you have questions about Pittsburgh, feel free to ask me if you want. Uh, okay. So yeah, just to finish that up, Thrashton. Basically, I don't really know the difference um, enough to comment of why I would use one or the other. Like I would just use data vector and be done with it until it mattered. But you know, obviously there are different things that people need to do. So it depends. Anyway, um, I couldn't possibly explain why. Like I don't know. I just know that when we moved there, the quality of produce that I was able to get was very poor, no matter where I went. And like we went shopping in Boston again, or like for the first time, and like the produce is already better. So I don't understand what the difference is. Like it doesn't make a lot of sense to me. Uh, but yeah, I you got me. Okay, so yeah, this one is like very similar to this one where we just kind of ignore the left and we traverse over this list and then we negate. So we should get right -1, -2 inside of a list, I guess. Uh, V. Yep. Cool. Just for reference for anyone that hasn't been here before, I haven't done this like this book in quite a while, so I'm just making sure to refresh my knowledge on like the operators and what to expect from traversals inside of the optics library, and then we'll continue going to traversal actions, which is like the next section. Yeah, yeah. Feel free to hit me up on Twitter for whatever about Pittsburgh. I don't know. I mean, I could help you decide where you want to live or whatever if that's helpful. Um, I don't mind answering that kind of stuff. Okay, so this one, element of worded one. I don't remember what this does, so we need to go find out what element of does. I mean, maybe we can guess. Oh, okay. I guess it's saying set the first element to leather is what it's saying. Okay. That's probably fine. We might be able to figure that out. Anyway, now that we've seen it, we can keep going. Okay, so we did this. These are just exercises. Yeah, this one was kind of cool. So set all of the characters for the second word to X's. That's what this is doing. So do all kinds of weird stuff. Again, I don't actually know when this stuff is useful yet. So hard to say. Anyway, here we go. We're into new stuff in theory. So traversal actions. So far, we've been doing traversals in terms of actions you already know, but traversal has a new action or two of their own. These new actions are based on the traverse function from Traversable. A primer on Traversable. If you're not familiar with, taking a few hours. I assume this means just the traversable type class. Yeah, so with sequence and traverse, right? So if you're super unfamiliar here, basically what this is doing is flipping a structure for traversable and applicative. So if you have a traversable of applicatives, you can have an applicative of traversables, something like that. And this is this comes up really often, like way more often than you would expect. Um, and so traversals are pretty useful. And traverse is basically what is it? I guess it's sequence a dot map or something. I don't exactly remember. We can look it up. Type traverse. So we take okay, right. So we're embedding applicative structure into A, and then we're embedding an applicative structure into T of A, and then flipping. So it's looks more like a bind followed by a sequence A. Let's see. We can actually just look up the source code as well. Because I assume that it has a default implementation. Oh yeah, okay, so that's right. So fmapf, which is basically what I just said, and sequence A. So cool. Now, this is a very general function, so it can be tough to see what's going on at first. We've already talked about, like, I already know what this does, so yeah, like here's a good example of something that it can do. So if you have a list of justs, it will accumulate all of the justs or give you nothing. So we have T F A F A. This one's interesting, actually. These two make sense. This one's kind of strange, but I guess I haven't really thought about what that should do. This is kind of seems like a strange place to use sequence, but I mean, it's just for demonstrative purposes. This one makes sense. So you have like a bunch of IO operations inside of a list, and then you want to just have one single IO of that. Great. And then, yep. So here's the definition that we were looking at before. Yeah, I don't know that that's confusing, but I guess it depends what your background is, right? Like if you've done a ton of Haskell, then that's not going to seem so confusing. Not that I've done a ton of Haskell, but I've done enough to see this before. Takes an effectful handler function, runs that on the elements, then sequences the effects to the outside. So there you go. I don't think about stuff like this very often, but that's pretty useful tool. Like if you gave me a bunch of stuff, can I actually interpret them the way I expect? Yes or no? Okay. Very cool. Yep, we've seen this before. Okay, cool. So traverse on traversals. So how do optical traversals relate to the traversal function? Traversals gives us a way to sequence to do gives us a way to sequence effects from any possible focus of a structure, not just those values focused on. Okay, so A to FB SFT. Lens like. Traverse of traverse. Okay. Okay, so let's put these in here. So okay. Sorry, sneeze. Text read maybe. I've never used this function before actually. G prime. So traverse of both read maybe one. Okay, so we're gonna try to read these, which it's gonna produce. What's the oh, right. So we should get maybe A, right? So we're gonna have a tuple just one, just two, and then we're going to traverse. So we're gonna end up with maybe int. Sure, that seems reasonable to me. G. Yep. And then if we put, I don't know, hello in here, then we should get nothing. Perfect. Seems useful. Okay. Yeah, we just looked at that, so fine. Just like traverse, so we can use it with any effect which has an applicative instance. Let's try it with the list effect, aka non-determinism. Data car, so we've just imported the whole thing. So H prime. So this is going to be a list tuple car. Although it's probably unnecessary to even define this in this case. We need to give the type here because read maybe needs to be specialized. So traverse of both apply a function where we embed an a b. Okay, so Right. So this is like the way the list applicative works. That's actually kind of strange. Okay, so this is a weird one for sure. You have to remember how the list applicative works, I guess, because it's sort of strange. I think we could write something like right. So when we think about just the list applicative, we can do something like this, where you put in a bunch of functions into a list, and then it will apply them to whatever you're, operating on. So this is taking this function times 2 and applying it to every element over here, or times 4 and every element over here. And that's exactly what we're doing here. We're embedding these functions. They're not these aren't partial functions. Like, I'm sort of expecting to see 2 lower and 2 upper without this C here. But it's got to be an A. Well, it's not applicative as well, right? It's traverse, which is a little different, but this is kind of how I'm thinking about this anyway. Maybe that's helpful, I don't know. Okay. Since we can compose traversals just like other optics, we can get pretty wild with the idea. Composing traversals builds a sort of traversal tree, just like composing folds does. The applicative for the list effect will find all possible combinations of each branch of the traversal tree. So we end up with something like this. Ah, right, okay, because we're doing traversed here. So okay, so we're basically adding another layer here, right? So that's what the traversed is doing. So we're applying this function to every combination of A with B, C, and D. That's kind of strange, but okay. Look, I gotta see some more like practical uses of this. Like, I don't know where this is exactly useful, this formulation of this, but we'll see. All right, so all right, the classic validate email one. put that here. Actually, I'd prefer that. What could this possibly? I mean, sure. It doesn't really matter to me that is that way. Okay. Traversed. Okay, so traverse over all of the things, focusing on the second element, validate email. So can I actually like get the nice? I think all we do here is just I just realized what this is. I always love the examples in this book. They're very funny. It's the Teenage Mutant Ninja Turtles. And then, you know, what we could do is say emails correct at this whole thing, which is kind of nice. Okay. And then, oh my gosh, can't type. So we'll see how long I last today, but I've been having pain from sitting. I think I got some pinched nerves issues. I need to go sit, like, I need to go see a chiropractor, but I don't have my health insurance card right now. I just moved, so I had to switch health insurance. So anyway, a lot of information, I suppose, but I can't quite sit down as long as I usually do. But I do have a standing desk coming on for Thursday, so hopefully hopefully I have it set up by Thursday. But my setup is almost complete. Almost complete. Okay, so we get right. So we need to see. I got a Veridesk. They they have like a 5-year warranty, and they have like the automatic up and down buttons and stuff. So I'm gonna try that out. The desk that I had in my old office was, I don't even know what it was, but it was a lot more expensive than the Veridesk. But I'm concerned about getting a cheap one because I use it. I'm gonna use it all day, every day for the next who knows how long. So it's important. It was important to me to get like something quality. So I'll let you know if I actually like it. But it's just their website's a little annoying. It's just this standing desk here. So they're not cheap, but like, yeah, I can let you know if I like it. But I wanted a bigger desk. So the current desk I'm working at is like 45 inches or something wide, and so I don't have a lot of room to maneuver. So I upped to 60, and then that yeah, it's it's what you need if you're gonna do it every day. I think. I think, but don't quote me on that. I am not an expert. In fact, I don't want to spend time searching for stuff, so I kind of just bought the thing that seemed to make sense. All right. So I'm wondering if this will work with multiple errors, and my guess is no, but because there's no monoid enforced for the traversal to make that work, but we'll see. So if we do k prime, we get that, but what if we make another error? Like, what if we do this? I can't imagine that we will accumulate the multiple errors, although maybe that's what the next section is about. Okay, it just shows the first one, so it doesn't have any way to accumulate the errors. I don't remember how you do that, but I think somehow the applicative one lets you do that. Okay. Ah, right, here we go. Validation type. Okay, so instead of this, with Ken, when do you start your new job? Do you know? I assume it's in Pittsburgh based on what you just said. But you're probably not working remotely for now. Or sorry, you are working remotely for now. Okay, so I guess validation just enforces that there is a monoid instance between. Oh wait, well we're just saying list of string here. So it just it just uses this monoid instance to make that happen. We can go look at it real quick. Success, failure, dot pure. Already started. Ah, I see. Yeah, that's kind of interesting to me, considering like what's going on right now. But companies have to operate in the way they have to operate. So if they feel their engineers need to be on site, then that's all you can do. Okay, so yeah, we'll just do this. That should be fine. So this pure is just the list version of pure for reference, if that's not clear. And then actually this should work just the same. The only difference will be the result. So oh, is that this is failing? Okay, so I need to probably okay, so we rewrote package YAML, then we restart COC, and I don't know that there's an equivalent way to do that here. I mean, we can just we could have just loaded up either, as in like what it was doing here. Okay, so now this should compile and work. So J prime still works and it returns a success, and K prime will accumulate all the failures. Wonderful. And then I quickly want to just go look at the validation to see how its applicative instance is written. VAP EALT. Descriptive. I like it. Yeah, that's okay. That it just, that's all you need to know. I I don't love this. V apply. This is really weird. Because these are on either types. What is that noise? You probably can't hear it, but is there any documentation, or is it just, I mean, I'm just confused at why these are implemented. Or like, what is this? That's interesting syntax. So it's just like, what is this syntax? I don't know that I've ever seen this before. How does this differ? Does anyone know? How does this differ from just saying write underscore? I've never seen this syntax before. I don't think I have anyway. Case B of. So if it's a left, append it. Sure. Well, append it, if you will. If it's a right, just return M. Anyway, this is weird to me. I just want to ensure this compiles with nothing turned on. Yeah, that's what I'm kind of wondering. No, this just compiles. Like there's like, to make sure I'm not insane, there it is. That just compiles. But it must be exactly the same as writing this, I think. But here we would need an extra set of parentheses. So that's kind of interesting. It's like you're throwing away the result, but you don't want to write the parentheses, I guess. And then I also assume that you don't need to bind them explicitly to the constructor. So that's kind of interesting. But as far as I can tell, there's no, yeah, the only language extension we have on right now is template Haskell. Oh wait, no, that's not true. Let's do something slightly different. No, it just compiles. So I've never seen this before. If anyone wants to quickly like find that syntax somewhere, that would be cool. But that just works, so that's kind of interesting. There's a classic, you learn something new every day. I don't know why you would use that. Yeah. Hey, by the way, yeah, we moved to Boston, so I'm in a whole new apartment actually. That's why I wasn't streaming last week. Although maybe you just didn't realize that. It was a pretty stressful move, but we made it work. Okay, cool. So, basically, this chapter was like, or this section here was just a reminder that um, validation type exists, which is useful. We learned some new syntax, although I don't think I'll ever use it, so I'll promptly forget it. And we got to experience some Teenage Mutant Ninja Turtles, so pretty good all in all. Okay, if you prefer having the arguments flipped, there's also for of, which behaves the same as traverse of. And then there's also sequence A of. Okay. Oh, that's cool. That's super neat. Right? Because if you would run a sequence A on a tuple, it wouldn't work here. Because you don't have the right type inside. So I think that if you tried to write, for example, sequence A just oh, this actually works. Right. Okay, so you see what's going on here, maybe. Um, because this is a list of character, that works. And then we just end up with the list on the outside, and then each character on the inside. So, yeah. That was a bad example. If we do if we instead do t.pack, think that this will fail. Yeah, because we no longer have an applicative, which was the point. Like, I'm trying to just point out that it would behave differently, but this allows you to sort of override the behavior, assuming the inner one is not, or sorry, the functorial uh element, component, piece, I don't know. Anyway, okay. That might be useful. So this one is both. So focus on both elements, traversed them with sequence. All right, because it's a list. So we want all elements of the list. What if this thing has multiple both dot traversed. So what I want to know is if I had banana and then just oranges, what does this do? Because this type checks, but what does it actually do is the question. Because I don't know the behavior. I mean, obviously we're gonna flip the just on the outside, but it's interesting to me that this is a tuple. but I guess that's the outer component. That's a very interesting structural change. So I'm gonna guess that we're gonna get apples, bananas, comma, oranges in the tuple. Yeah, but that's a weird structural change. Like if you're not ready for it, and I really wasn't, because you're reaching into multiple layers of structure and pulling the just out. That's cool. I can see how this is really powerful as well. These tools are very powerful. Using them is going to be hard. Although we should get to exercises soon, so we'll see how that goes. Okay, so traverse of has an infix notation, which is that. So I think the percent tilde, if I remember correctly, is over. Yeah. So this is like over with some extra sauce, something like that. Okay, so we can write, everybody likes extra sauce. Well, that's not true. Hey, the Cupid King. What's up? Haskell? You do not like Haskell? Or are you excited to see Haskell? Which one? Hard to tell. Also, hello. How are you? We are, I don't think I've seen your name before, so we're currently working through the Optics by Example book by Chris Penner, which you can conveniently find there. Although, if I remember correctly, he's having issues with the printed copies. But I think the lean pub's still working. Yeah, this is the Haskell love symbol. So I think they were selling T-shirts. I don't know if they still are. Oh, wait, print this here. So Haskell.love, and somewhere on this website, I think they had like merch, but I don't know where. So anyway, just keep in mind that if you're interested, I think this is still a thing. I don't know when this is happening. I forgot, but it's there. So that's that symbol. The shirts are really nice, actually. Oh, nice. Where did you see Haskell before? Yeah, so we've been streaming for just about over a year now. It was a year like a month ago as an affiliate, and we've been kind of just learning Haskell this whole time. So on the stream, we kind of stick to statically typed functional programming languages. So we've done Elm and PureScript and Unison on the stream before, but we're mostly doing Haskell. Yeah. Okay, so let's rewrite this. So we don't need that outer set of parentheses, so we should be able to write one. Where did you experience Haskell before? University or something? Both. Yeah. Freshman year of college. Nice. Yeah. The we're pretty far from the basics these days, but I really do need to step back and work on a more basic set of videos. So like I have a bunch of videos on YouTube of me working through these books, and I need to update those videos really badly. But that's kind of the idea is we'll work through these books so that other people can also watch me struggle and hopefully learn something. And I don't know how many views. I don't get a lot of views on YouTube, but I don't really care. If anyone watches it and they get anything from it, then I'm happy. So that's kind of the goal. Yeah, that's actually a great question. Well, what did you learn? Or do you do you even remember? Depends how long ago it was, I guess. Not sure I could recite things from my freshman year of college. I probably could, but I'm not gonna try. All right. Okay, so using traversals directly. So as it turns out, the lens library's Van Laarhoven encoding means that most traversals can be used as a can be used as is as a custom traverse function. That reads interesting. Don't worry if you don't know what Van Laarhoven encoding means. We'll chat about that a bit in the next chapter. Instead of using traverse of or the infix operator, we can often just use the traversal itself. Oh, that's cool. So they are just traversals, so you don't have to do anything. Ah, okay. Yeah, like strong typing and recursion. Yeah, it would be great for that. So I think something that was kind of funny is I think literally the first day we did the optics book, somebody was already talking about Van Laarhoven lenses, and we finally got to that term in the book. So it took 157 pages, but we got there. We're actually almost halfway done with this book, although I've been moving pretty slowly. It's pretty. There's a lot of pretty tough exercises. All right, so we don't even need this. That's kind of cool. Fair enough. Yeah, that's true as well. Yeah, like making sure something is able to do tail call is important. You just don't even think about it. At least I don't think about it. Maybe I should. Okay. So basically the traversal type is specialized such that we can do this. Yeah, so tail call optimization. I think it's optimization. Yeah. So I don't know how to explain it in a simple way because I don't really think about it ever. Maybe Ken can. But in languages like Scala, for example, if you do recursion, you can run into Stack Overflow errors because of the way the recursion is done from the language's standpoint. And you have to make sure that I think you just, like you say, your computation is in the tail position so that you don't run into these Stack Overflow problems. Is that approximately correct? It probably isn't. Oh, somebody just followed. Oak Janai. Okay, John? The second? I don't know. It depends. Hello, first of all, and thanks very much for the follow. Hopefully you're still here. Okay. It's probably more complex than what I said, but hopefully that gives you the gist of what it's all about. You can go look it up and learn a bit more. Okay, I'd recommend avoiding this style. It's unnecessarily confusing, unidiomatic, and doesn't translate well to other optics libraries. It's sometimes useful to know that it exists. Okay. As a fun bit of trivia, the fact that traversals match the traverse function on their own means that the lens library implementation of traversa and that's cool. That's kind of neat. Okay, so exercises. This is what we live for, folks. Stuff to do. Oh, that's weird. Cube King, thank you so much for the follow. Appreciate that. Yeah, I think like tail call will lead you down a small rabbit hole, and it's probably it could be relevant in the language that you're thinking of. And if you run into Stack Overflows, you know that's usually one of the leading causes, I think. All right, so the way this works is I think we're in 7.4. 7.4 exercises, traversal actions. Basically, we just kind of work on these and talk about them together. So we're gonna have the following. Rosebud. Okay, so that's true. That's very true. Or traversal. All right. So basically, we want to fill in the blank such that the result is nothing. And in this case, I think that we just want traverse of. So can we just do no, we cannot. Oh, it's just sequence A of. There you go. Hey. Oh, okay, Johnny. I like it. Nice. I'll try and remember that. Nice to see someone writing Haskell on here. Yeah. So there's actually a few folks who are writing Haskell relatively consistently on Twitch. So you may be familiar with Soding, Tsoding. On Thursdays, he codes Haskell. At least I think he's still doing it. There's someone Jappy, although I haven't seen him in a while. I think he's just been really busy. Jappy. And I'm also familiar with Freeman X42, something like this. 42X. I think it's this way. I'm familiar with these folks offhand that are doing Haskell regularly. There's also some. Recently, I've seen one of the maintainers of the Haskell Nix packages. Yeah, I haven't seen Puff and Fresh streaming in a while. Occasionally, he drops in on the weekend streams, so that's kind of cool. But I have seen him around, and then also, there's another Norfair King, I think. What is his name on here though? That's his GitHub. I can't remember the name, but there's a few people that are streaming Haskell pretty regularly these days. But no. Anyway, let's see if we can get this right, or if this is right. Oh, prime. Oh. But yeah, I'm here Tuesday, Thursday, and from 7:30 Eastern time to 10:30 typically. I'm also doing a weekend thing right now, but it doesn't really have a defined time, where I'm working through Sandy McGuire's new book. I'm basically helping him review the new book. So yeah, we kind of have like our own books, and then we have some project-based stuff, and then we also do the new thing that we did is this review. I kind of want to do more of that. It's really fun, actually. It turns out that people find it useful to like work through their libraries and like look at their confusion. Oh yeah, yeah, it's super late. Um, I don't know what the time difference is to Japan. I guess it would probably be something like um, 8 hours before. Is it like noon in Japan? I'm just guessing. Like I truthfully don't know. I think Hawaiian time is 6 hours behind. Oh, I was pretty close. Yeah, yeah, okay. Pretty close. Okay. It's funny that I was actually that close. I mean, it can't be that hard to guess. I know Hawaii, so that's not, you can only be a few hours off from them. Uh, okay, so we got P prime sequence A of traversed dot one something, and then this. Please let me copy it. Okay. So this we may have to specifically just write as int, which should help. And then it's gonna complain here, probably. Once we put something here, we should be okay. Oh wait, this is the result. This is the result. Doesn't go here. So okay, we want we're just flipping two lists, so it's why is it not just the same? And why do we need this 1 here? So the traverse goes through this inner list. So is this just... Is this supposed to just be... For reference, I'm just guessing. Oh, okay, Johnny, did I ask you where you... What do you use Haskell right now, or is it just sort of interesting to you? That's another thing. I like to ask people that. So A1, C2, A1, D2, B1, C2, B1, D2. Yep. So I knew that I needed some sort of list object, and obviously we need a tuple object, but somehow we need a list object on the outside. And so that's how I kind of thought we need a string on in the first position of a list of tuples. And then this kind of looks like the all combinations of A with C and D, and then B with C and D, right? So that was kind of I kind of guessed, but you know, it is an educated guess. I don't use it often right now. Right, OCaml for work. Yeah, I assume there's a lens library in OCaml as well, so I find them pretty useful. It seems like I would use them a lot when I start trying to apply Haskell to my data science-y type work, then I'm gonna want lenses. Hey, Hurrats and Plots, how's it going? How are you? But I haven't really done Haskell for data science yet, so that's kind of what I need to start doing to make this more useful. Oh, so yeah, I think you were lurking on Sunday or Saturday whenever we were doing the algebra driven design thing, and Sandy dropped 20 subs in the channel. So yeah, that's how you got it. Yeah, I don't know why he did that, but I really appreciate it. Yeah, I guess so. It counts, I guess. Um, so that's good. There you go. What are we doing here? Cute. Sequence. Yeah, hopefully this weekend, if we do it again, then you know, you can thank Sandy directly. I hope that he'll be around next weekend as well if we continue doing it. Zip list 1 2 zip list 3 4. Okay, so if I recall correctly, a zip list is, it doesn't behave like regular applicatives for lists. It does yeah, by element. So can we just get zip list? Yeah, so let's just do 2 for now. Okay. And then we just want to flip them. So I think we just write id. Oh, no. We need traversed. That should work, I think. There we go. Yep. So we need to focus on the elements so that we can get to these, basically. And then that will be enough. Okay, next one. All right. Oh, I need to put the result here. Zip list get zip list. I guess I don't have to, but the whole goal when people look at this later is that they can see this. I don't want to write that whole thing. That's really long. All right, so we're zipping along this. So this is 1, 2, 3, 4. These ones are a lot easier because like you already see the structure. This one was probably trickier. Yes, I don't know. They're kind of the same, I guess. A1, B3, A2, B4. Yep, that looks right. Cool. Result 0, where result equals traverse of this looks weird. How strange. Okay. So let's do this and see. Do I want the lazy one or the strict one? I mean, probably just the lazy one. Yeah. Agreed. This is quite weird. All right. So what the heck are we going to do? Okay. So we're going to basically go over all of these and run this function. So we need to, I think we need to use beside here. And we're going to say beside traversed both, I think. Okay, so let me let me break that down a little bit. Okay, so we're taking the value. Yeah, it's so this is like, I am very good at these kinds of puzzles, right? These are puzzles. This is not practical. Well, maybe it's not practical. There's probably some interesting cases where these are very practical. But I like these puzzles a lot, which is part of the reason why I do this. So I can see myself wanting to use lenses though for more practical things. So it's exciting and fun. So thanks for that. That's Zefchip is the author of this book, by the way, if you didn't know. So thank Chris for an awesome book if you could. It's very fun. Nice. Okay, next. Nobody has had any encoding issues, right? No, you haven't seen any? I've been very concerned about it. I haven't noticed any. I don't have any drop frames on my end, so I assume that means you won't have any issues on your end. Oh, okay. Good, good, good. Oh, cool. Doing an interview with LeanPub about the book this evening. Is it in person or like just via chat or something? That sounds interesting. Could you? I assume you'll share that on Twitter, so I can. Is it being like uploaded somewhere? I just want to make sure I can share that. Oh, they have a podcast. That's interesting. That's cool. Thank you. Although I'm not listening to podcasts much these days. That sounds really cool. I'm not riding the bus anymore. Fair enough. Or I might ride the train if I change jobs, but right now I'm working remotely. So I used to crush podcasts on the bus, but I'm not riding the bus anymore. Okay, so these were all one fill in the blanks. See page 146. Page numbers might get out of sync a little bit, but that's not a big deal. So this is 2. Man, I hope that I can use these more frequently because it seems very enjoyable. I gotta figure out a better way to type that. So like, I'm not very good at, I touch type, but I'm not very good at keeping my fingers in the right locations. So like typing that operator is a little frustrating because you have to, like, the reach is wide, I guess. I don't know. It feels weird. Okay, so I'm not, yeah, I think I'll just, I try to touch type. As you can see, I make issues. I have issues, make issues. The problem is oh, right. Import control lens. So we have to take right. I'm stupid. So this goes here. Then we take the function first and stick that over here. I think. What? I'm clearly thinking about this drastically incorrectly. So this, yeah, okay, I just have these backwards. These can go away, I think. And these can go away. All right. So the left side is a focus. It's not a function. Why am I confused right now? This is this function. Am I just losing my mind? S is a structure. The structure before, or focus before. Apparently I haven't done this in a while. I'm now officially confused myself. I need to like go back and think about that, I guess. I think the result, I mean, if it compiles, it should be right in this particular case. I mean, this is the same thing. I just need to change the structure, or I just need to change the, yeah, the structure. I don't really do that. I don't think. We're just flipping these two things and changing this. Yeah, I don't think I need to write that one. Okay, so data user count. Okie dokie. All right, so given the following data definitions, right, I should put that here. I guess there's a small typo here, Chris. If you're still there, we can share that. Yeah. See ya. Thanks for hanging out. Good luck. Okay, so given the following definition, write a validation function that uses traverse of to validate that the given user has an age value above 0. I don't need to write that. I mean, we're using either type, so clearly that's the point. Can you guys hear the bus as it goes by? Or the train, excuse me? I tried to make sure I was talking while it was going, but I'm not sure if you can even hear, if it's even picked up by the mic. We didn't have that in the old setup, so a bit. Okay, no, that's unfortunate, but I mean, I don't know what else to do. Yeah, it's not even too loud to me, so not a big deal. Yeah, exactly. If I'm quiet while it comes by, you'll never hear it because my my noise gate should cancel it out. So we could write this in a point free style, I think, which would be really nice, potentially. So we know we need something and something else. I had 9. Hey, how's it going? Nice to see you. Yeah, you were also the I don't remember if you, I think you were actually participating in chat on Saturday. So yeah, you also are the benefactor of a gifted sub. Okay, so we're going to be given an account, which means that we need to have lenses that get us to the age. So we should just be able to do, that goes over here though. Over here we still need a function. We need account, sorry, account dot age. Oh wait, user. And then over here, we need a function that basically embeds the either. So we're going to be given an n, and then we can say What's the best syntax to use here? Let's see here. Case. Can I use this here? I never remember. Illegal lambda case. Oh, it just, okay. Yeah, okay, I can't use that there. Sometimes I forget that this is possible because I think that this reads nicer than using like an if. Someone's welcome to disagree with me, obviously, but I kind of like this better than an if statement. Like I was gonna write /n if n greater and then. I don't know. I don't know what's more readable. Someone has to decide for me. I want to write this, so we'll write this. And we'll see if this works. So we would write so valid count so we need a string hello. Well, yeah, sure, doesn't matter. And then we need a user with a name. I don't know who I want to use. I won't ask how old you are. We'll guess 25. Okay. So validate, oh, reload, validate age, valid account. Yep, we just get a right, perfect. Validate age, invalid account. Oh, right. So age is not possible, 150. Okay, cool. All right. Okay, so this chapter assumes you're working with a Van Laarhoven encoded optics library. You're using some other library. Look for a traversal helper or a Van Laarhoven adapter. Most libraries will have at least one of these. Here's some common adapter. PureScript ProFunctor lenses uses Wander. would like to explore lenses in PureScript at some point. We still need to finish our game. I completely forgot about it. Maybe we'll work on that on Thursday. Not forgot, I just haven't been working on it. Optics uses Traversal VL. Okay, so optics look like traverse. No such helper exists. So there's a good reason a traversal helper isn't necessary in Lens. Most of the Lens library is encoded using something called Van Laarhoven style. Hopefully I'm pronouncing that right. The Van Laarhoven encoding is just one of many ways to implement optics. It's the variant that the Lens library is built in for the most part. The gist of it is that Van Laarhoven optics all look something like this. Yep. All of the optics we've learned so far can be written as some kind of lens-like. As we just learned, the shape of a lens-like optic matches the type of the regular old traverse function from the traversable type class. S equals GA. T equals G. Sure. Then we get the type of the traversal. Different optics have differing constraints on the effect type F. If we strip off the applicative constraint, we end up with the signature of an arbitrary lens-like. So like Von. Yeah. Not Van. I'm pronouncing it like an American. Von Laarhoven. Is that better? Hope so. Nice. That's good stuff. Good stuff. Okay, so a lens has a functor constraint, traversal has an applicative constraint, a fold has a contravariant and applicative constraint. Yeah. Okay. Cool. The symmetry we see in these shapes is why we can compose optics of differing types together. Every optic is actually the exact same type plus or minus constraints on F. As optics are composed, the constraints on F are gathered up. From these expansions, we can see that the optics we've learned so far are just slightly altered versions of the traverse function. Most optics are just really traverse, wearing different pants. Okay, cool. Okay, so our first custom traversal. Now that we understand that Van Laarhoven optics are just a function implementing a simplified version of traverse, which only works only on lists. Call it values. Okay. Okay, so expand this. Okay. If you've written an instance of traversable for lists before, the next bit is going to look pretty familiar. Yeah, I mean, that's not surprising at all. It's exactly what we're writing. Okay. So we need an F. So that gives us FB. I hadn't thought about traverse in a while. Oh, right. This is this is just a simple HLint change. That's kind of wild. That seems unreadable. So given an X, that's pretty cool actually. I mean, I don't know that I would ever write that first. Yeah, I mean, like, sure, like I see how that works, but it doesn't it doesn't really make me very happy. Although we could change it just a little bit to make it a little more readable and say, right, instead of wait, is there an underscore there? No, there isn't. So we could say ac and then right Now again, it's going to ask us to reduce again because it just wants us to get rid of this Oh wait, no, it's just telling us to get rid of excess. That's fine. And as long as this doesn't complain, I'm okay with this. Right? This is more readable. So your accumulator is just what is the accumulator again? It's just some applicative. That's kind of cool. I would never write this in terms of a fold, but it's, you know, doing the exact same thing. Although I guess that's why it's saying it's a rewrite, because of how easy this is to rewrite. I'm also not sure I would write this as a lift A2, but I haven't thought about lift A2 in a while. I mean, it's basically just the same thing, so anyway. Okay, let's keep reading. This is interesting. How is it implemented for list, actually? So let's look up yeah. That's again, that's assuming you have, well, that is traversable, right? It's the same thing. But we don't have a traversable constraint, so we can't actually use sequence A, right? That's like defining traverse in terms of itself. That's the problem. I think we're just trying to write the specialized instance. So it is traversable, but we want it for any applicative, not any traversable. Yeah, but you know, I see where you're going. Why doesn't this come up with the one I'm looking for? How do I just search for list in here? My Let's do this. This will get us where we need to go. No, it will not. I know what we need to do. We need to look up traversable. And then we want to source. Okay, so it's defined as lift A2, which is fine. It makes sense. And lift A2 should be defined as, I think, what I defined it as. Does this actually end up taking us to the right location? I'm not sure why it's so slow. Lift A2. How is this defined? Source. fmap fx. Yep. So it's right. It's taking this and yeah, perfect. Okay, cool. Fine. This is more natural to me still, but that's, you know, it's not that big of a deal. All right, so not terribly tricky. So now we can just use this thing apparently. Well, we should write something in here. So, where are we at? T. So to list of values. So that doesn't do anything. Okay. It works just like traverse. I suppose it does. Okay. So let's write this. Traversals with custom object. Bank software. And here we are. Show make lenses transaction. Oh, this doesn't get formatted? Seriously? That's kind of funny. Can we? Wow. Okay. That's kind of funny looking. I suppose this is what I'm looking for. Although, I guess I'd be fine if they were just on the same line. I don't know. Bad style trademark. Yeah, I guess I've never seen this before, but if I have them this way, does it like? It does not. I don't know. I wonder what formatter he's using. Or if it just, that was handwritten. I'm unsure. Okay, so it's smart enough to write the correct amount. Neat. So now we can write new type account transactions. Yeah, see, that's another thing is I would really like some space here, I think. I think that's really the style I'm looking for, but all right, so we're writing a, what is this called? A event sourcing model or something. I think that's what we were talking about this weekend, weren't we? Something like event sourcing pairs this model. It's like you can fold over everything to find the current state. Okay, so now we have an amount and a transactions lens. Okay, now we have the pieces so we can represent a simple bank account. Get all transactions. Sure. UV. Yeah, I think like this idea is really interesting, and I would like to. I need to think about it more. Like, when should I use this model? Like, I know that I've been thinking more about modeling computations like this using lists, but not so much using fold, if that makes sense. Like, I have Google Docs, for example, that use sort of an event sourcing model, and I almost didn't realize I was doing it, which is kind of cool. So anyway, it's pretty neat for sure. So I don't really feel like typing this. I'm getting tired, so I'm gonna start being a little lazy. But like, this is very trivial. That's very trivial code to write. It's just copying and pasting. So Alice account to list of transactions dot traverse. So focus on the transactions and then traverse the list and then just accumulate them. And that's what we do. Okay. So we've gone in on domain-driven design, the best way to manage it in a functional language. Yeah. What's the domain, I guess, right? Because, so, you know, I saw Sandy talking about domain-driven design earlier a little bit, but I didn't read a ton of it. Because we're doing his book, the algebra-driven design. I'm not sure if I mentioned that before. I probably did, but I'm not writing software professionally, so all of these buzzword driven design things don't really make a ton of sense to me yet. So anyway, all right, so our manager has given us a task. There was mention of the book that helped understand like domain driven design in functional languages, but I don't remember what it was. If you're in the functional programming Slack, I did see talk about that in, I think it was in the Haskell channel, actually. I have no idea if that would be interesting to you, but I'm just letting you know. All right, so they need a traversal, which focuses on only the dollar amounts of deposit. Hey, Oren, how's it going? So we want to focus on just the integers in the States now. Nice. Oh, right, because you were moving from Panama? Is that right? Nice. Oh, there you go. There's a book. I don't know if is that the one? That's probably the one they were talking about earlier. Ah, shoot. Well. But that looks like a Haskell book. Maybe we should pick that one up. Has anyone read that book? Does anyone in here know about that one? Thank you. Yeah. We just finished our move as well. Probably wasn't as hard as yours, but it was a little tough, but we got there. free monads galore. Actually, that would be really good for me, because I would like to spend more time with free monads, and that's, yeah, that's okay. We could also convert it to using some other thing, right? So it doesn't have to use free monads. Free monads galore. Okay. I highly doubt they're gonna write, your manager is gonna say, I need a traversal. What do you think? Has your manager ever told you that they need a traversal? All right, so we expand out the traversal to from its simple representation to its full representation, and then into its traverse-like shape. So deposits is a traversal prime transaction int. Nope. I'm doing the exact same job. I'm not changing. The only thing that's changing for my job is that I'm working remotely right now. That's it. And you know, I sort of got lucky. This is gonna sound weird to say, but I sort of got lucky that COVID happened, because it made my managers realize that I can still do my job perfectly fine remotely. And so when we found out we need to move, they were fine with it, because we had been working remotely for a few months and there was really no plan in sight for us to go back into our office. So COVID sort of helped me, and that feels really weird to say, but it's not, it kind of did. Yeah. Am I still thinking about the dark side of programming? Yes, but do I want to leave my really, really stable job right now? No. Does that make sense? Like, I'm considering what's going on in the world and the daily Twitter posts I see from people, being laid off from their jobs. I just don't think it makes sense for me to search for one right now. Okay, so we're gonna have an int f int, and then just the structure, and the result will be oh, that's not okay, right, that's not a result, that's the lens type. Because this is S T A B. Okay. So we're gonna get an F clearly, and it looks like we're gonna do probably something special here. I don't know what, but this is gonna be the exact same implementation as before. So it's just gonna be folder fx ac pure empty list thing. Oh. Withdrawal. So I need some special types in here. We don't want, okay, so there's some secret sauce in here. It's not really secret, I guess, but we can always listen to this later. So handler withdrawal, sure. I mean, we can just, yeah, let's, no, I have to use pure. That's the whole point, because it's an arbitrary f. So that was the right intuition. That's what I had before. Ugh. There you go. Okay, so for withdrawal, we don't want to focus on withdrawal transactions. We don't run the handle. Maybe I misunderstood what's going on here. What are we trying to do? They need a traversal which focuses on only the dollar amounts of deposits. Okay, so ignore withdrawals, only deposits. Got it. So, oh, I see. So we're ignoring the handler completely, other than passing it onward. I see, I see. So f is going to take an integer. So I guess it's just, oh, okay, sure, sure. Deposit fmap. So we're gonna make an f of amount and then turn that into a deposit. Turn the inner value, the inner integer, into a deposit. Suppose you could also take a function that went from deposit to deposit, but doesn't really. And then does the exact same thing for the other components. And I presume that HLint will not try and update this because there's really no way to do it. The handler focus elements, pure ignores them. Weird, but okay. Peer ignores them. Not clear to me why that's the case. The handler accepts an int. I need to think about this a little bit more. Because I don't fully understand why that's the case. But okay. So we're gonna write so we have the deposits. We need to reach into the list and get, oh no, we don't want traversed, we want deposits, I think. $100. Oh, okay, I don't have any, I only have one deposit in there. Right. Okay. We can edit our deposit without affecting the withdrawals. It seems like a very dangerous function, but okay. Warning, when focusing a subset of a list like this, our first thought is often to look at using a helper like filter to implement the traversal. But you need to be careful. Filter is a destructive operation. It throws away any parts of the list which don't match. To understand why this is bad, let's write a bad version of deposits, which uses filter and observes okay, I see. So depending on the kind of operation that we're doing, interesting. Okay. So toListOf is only running things that use the handler, whereas over needs to be able to accumulate the withdrawals as well, because we're that's cool. It's not immediately obvious to me why that works the way it does. I guess it's because of the type of F. Right, because in that case, the type of F is something like F times 10. And we want to end up with a, yeah, okay. I'm hand wavy explaining it, right? But that's probably fine for us for now. We haven't learned them yet, but this version breaks the traversal laws. I'm not surprised by that. Yeah. Again, like that was part of the introduction to this book is like you can write a lot of lenses that break the laws, but sometimes they're useful. And I suppose this deposit function is possibly useful. I mean, I don't exactly see why you would want to do this, like why you'd want this deposits function, but I don't know. I could see this one. Filtered is deposit. Whoa. That's very poorly formatted. Um, yeah, there we go. Okay, so I think what we'll try and do is finish these exercises and then call it a night. So I usually stream until about 10:30. And I'm starting to get tired, and you can see I'm getting shifty in my chair because my legs hurt. Just stretch before bed. Okay, so amount T prime transaction int. So traversal transaction int, and therefore the actual type is applicative f int to f int transaction to f transaction, I think. Okay, so we're probably only gonna need f here because we have a transaction, and a transaction is just a withdrawal or a deposit. So we could just say withdrawal amount Okay. Okay. Go to rewrite the both traversal over tuples. Oh, yeah, that's actually a good question too. Although, if he's in the States, I don't remember exactly. I think you told me where you're moving, but it should only be probably a 2 to 3 hour difference, right? Probably not terribly far. Okay, so we want to write both applicative f. So right, we need A to FB, AA, FBB. uh, my traversal brain is. Can I write it with sequence? No, I can't use sequence. Again, that's the whole point. So what we need is this fmap fx fy. I think that's right. I should, for clarity's sake, call this both prime just in case. Write the following. Okay. We move this. So it should focus the amount of the transaction, but should reflect the change the transaction causes to the balance of the account. That is, deposits should be a positive number, but withdrawals should be negative. Okay. Something like that. That's fine. So we're on Y. So its type is going to be applicative F, int to F int. The starting structure will be a transaction, and the final structure will be an F transaction. And Y of a withdrawal will be withdrawal fmap wait, what? negate. I guess it's negate dot f amount. Does this compile or do I need parentheses? Probably need parentheses. Ah, yes. So this needs to come out like so. And then for a deposit, we will say deposit. Yeah, so there's part of the reason why this is a bad idea is like if you were to write this, it would type check even with withdrawal. I suppose it's problematic. Maybe it's not. I don't know. Seems like there's probably a better way to encode this data type to be safer. It would be pretty easy to mix these withdrawals and deposits up. I guess that's what unit tests are for, but yeah, -1 hour is really close, so that would be no problem, I don't think. Like East Coast, West Coast might be an issue because, you know, you either would have to get up really early or stay at work really late, right? If you needed to work. That could be. Okay, so let's see if this actually works the way we expect it to. Deposit 10. What is this query? We call it y prime. And then if we do withdrawal, it should say -10. Good laptop backpack. I don't know if my recommendation is good, but I've sort of been fond of the North Face backpacks because they last a long time. So I have a Surge North Face backpack, but they're kind of pricey for what they are. So I don't think it's a good recommendation, but it's the one that I have. All right, so this doesn't work. Why doesn't this work? So we take F, which in this case doesn't matter, and then we negate it and nothing changes. What? I don't understand. We'll come back to that, I guess. I'm probably doing this wrong. Maybe that's the issue. So there's another recommendation. 5 years, much longer than I've been using mine. I think I've had mine for 2 or 3. So, all right. So applicative f a to f a prime, either a b f either a prime b. Ah, right. We're gonna have to reconstruct it because there's no way otherwise. If I write pure X, then it's the wrong type. So I need to write pure right X. I guess. Assuming my thought process is correct, I'm still confused. So I guess we're gonna have, do we have one applicative here, or do we have 2? Like, is it F and G? I'm gonna guess 1. Okay, so we're gonna take an AFB, an S, a S prime, does this look right? So we have 2 A to B functions in two different structures. Yeah, I think this looks right. I don't know if it is right, but I think it looks right. So these are B. So F. So this is gotta be wrong, right? No worries. See you later. Until next time. Hopefully Thursday, I guess. Right, so this is the trick here. Hey, kitty. What's up? I don't know if you can hear that little kitty. You probably saw her walk up. That's my other cat, Layla. She usually doesn't like come in here, like bother me too much. The other cat is much more needy. So, right, this would be if I had a BB, which makes me think I'm doing this incorrectly. So let's just look at the answers, and then we'll try not to spoil them. So basically, I guess if we get rid of this definition and do this, it should still compile. That's kind of the idea. And right, we're calling this a handler, which is fine. So what we should be able to do is comment this out and instead write both traversal A there's the other one. I don't know if you can hear that. Okay, so that's fine. Hi, bud. And so this one should... What? What's the matter, little bud? I will pay attention to you very shortly, I promise. This should be... Oh, this can just be transaction int. Yeah, they're okay. So the one of my cats has already moved before, and so she adjusted pretty quickly actually. within like really overnight, she was doing much better. The one cat you can hear meowing right now took probably 3 or 4 days to really feel comfortable, but we just gave him his normal hiding spot, and he kind of chilled. He came out to eat and drink, and so we weren't too concerned about him. But it can take a while for the cats to adjust for sure. But he likes to he explores now and stuff. He doesn't spend a lot of time in our living room, but I think he will as he gets more comfortable. Okay, so in theory this should compile. Okay, well the bottom one won't compile. This won't compile, so let's get rid of that for now. I think I'm thinking of the type signature incorrectly, which is the problem. Like, I wonder if I need multiple traversal, either A, B, either A prime, B, A prime. Okay, and then yeah, I think I'm translating the type incorrectly. So let's actually think about the type a little more carefully. So the first one is this. So that's, and then let's right. The second one come here, you goofball. You're fine. You just want attention. I know. We're almost done. We are almost done. Yeah, it seems to me like I had the type correct. So let's just go look. I don't want to go too far, so let's scroll nice and slow. That wasn't. Oh, right. Let's actually check this while we're here. Yep, that's right. That's right. What? How does that make any sense? That just can't be right. I don't believe that that's correct. But I don't know. Oh, this said failed. No modules loaded. So All right, we may have to call it because this kitty needs some attention. I'm starting to feel bad. That works. Was it a situation where it said no modules loaded and I ignored it? That's so strange. So this negate does nothing. I bet you it does something. One of these with withdrawals won't work. That's the key, right? Import control. Variable not in scope. Oh, right. That works. Okay. Hey, bud. Withdrawal 10. This can't be the right behavior. It doesn't make any sense. Why would you want this behavior? If we put that other negate in there, do all the other ones work? Gosh, I'm confused right now. So that one works? Okay, so this is... Oh, I get it. I now see why that has to be negative. Except I can't... Right. Okay, I get it. I see why that has to be negative. Now the behavior is very strange to me. But this F means focus or not focus. So if we focus it, negate it, then it's almost like when we return it, this is sort of the behavior when we return. And then that is the thing that flips it, because we need it to be positive. This makes perfect sense, actually, right? Because a withdrawal is not a negative number. It represents a withdrawal. So it's like withdraw $5 or whatever. But it has to be positive. Okay, no, I'm okay now. I was super confused. My brain was exploded for a moment there, but we're doing okay now, I think. But I think the logic is that F represents like focus on something, and then this thing represents like return the thing, something like that. So if you're going to end with an actual transaction, you do this. Like, well, this. You take the integer and you do that. If you're going to just focus on the value, then you negate it. And that's this side of the equation. And that's probably why he's writing it as lift A2 often. Although I guess it doesn't work here. But I feel like I want to ask Chris if maybe it could be clearer to explain this. But I'm not really sure. He did say it once, but it's tricky. It's very, very tricky. Okay, anyway, I think we're okay there. And that makes sense now. Yeah, this is exactly the same. So, well, we've looked at it. So let's just think about it. So you can't write it like I wrote it before, I guess. Like that's just not possible because this is a higher order combinator, right? So there's really no way to write it this way, I guess. Unless we write it as BB. Can we write it that way? I don't think we can. Yeah, because the structure needs to be this. So I don't think we can write it the way I was trying to write it. Where's the handler come from? Yeah, so like you can see that this looks weird already. Right? Like oh, we need rank and types. So like it's weird to write this type. For sure. This one doesn't fully make sense to me right now. Why is this a prime? Oh, there because we have already written left. That's fine with me. It just helps to be clear. So S, given S, take the left handler traversed over and then applicative S right traverse over handler. Okay. Oh, this makes sense. Like the implementation makes sense. But this is not super clear to me right now. I would love to know the more general signature for beside. Does it change it here? Oh, let's do beside prime. Reload. Oh, here we go. Oh, look at that. Okay, so I was just on the wrong. I was thinking about this incorrectly. I needed to write. Okay, let's put some notes here. So I originally wanted to rewrite this as A F B S prime F T prime. However, that isn't the correct signature. What it should be is traversal stab traversal E prime. Essentially only rewrite the final traversal and leave the input traversals alone. Does that work? Do. I just want to like reduce the width here so it's readable in the 80 characters or whatever this is. Okay. Cool. This makes a ton more sense. Like I think I would really like I think I'm going to ask Chris about this. It would be nice if there's just a tiny hint there. Instead of writing, well, maybe this hint is enough. Wait, I thought, what just happened? Why did I go back here? I think there's a issue with that link as well. Okay, so if we hit return to questions. Oh, that worked that time. What did I do? Okay. This hint maybe this hint could say rewrite only the final traversal. Is that like giving away the answer? I don't think so, but maybe it is. This certainly wasn't clear to me, like how to solve it. Do we see an example like this before? Because I don't think we did. Maybe we did. Let's see. Do 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 do. Do, 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 do. Maybe we saw beside earlier, and that was supposed to be the trick. But like, I don't remember seeing the rewrite version, so it wasn't clear to me that I should rewrite that. I don't know. What do you guys think? Any comments? Do you think it would be helpful? I think it would, but I also think it kind of gives away the answer. Ow.